Okay, so let's think about, you know, if we do something algebraically, we always like to look at it graphically as well, right? So let's think about this.
I have a question.
Mm-hmm.
For the change of x, why is it 2 first?
So it's always final minus initial, right? So the final value was 2 and the initial was 0. It ended at 2 minus. So if you start at 2 hours and you end 2 o'clock and you end at 10 o'clock, to find your time you go 10 minus 2, right?
Right.
What's the bottom?
For both.
Oh, okay.
So f of 2 minus 0 and 2 minus 0.
Oh.
So let's think about this. This is a graph. This is the absolute square root graph. It's shifted over to the left, right? So it should look something like this if you graph it. Right?
They were replacing the vending machine.
Oh!
I convinced the guy.
Oh, perfect. You're like, it's an emergency. My teacher needs it. Thank you so much.
Change.
Thank you. Okay, let's start with this. Fiber 1. It's because they're giving us lunch today. That I have this meeting with the administration, and they're getting us lunch. So I didn't bring anything.
Oh yeah, it's really cold.
All right.
The water
I know. I'm out of water too. Just generally low on supplies. Okay. Thank you. This is f of 0, right? And this is f of 2. You guys agree with me so far?
Yeah.
I didn't do anything fancy.
Is the first dot the
Hmm?
first dot
F of 0, yeah. Why is this frozen? Okay. Now, so what does this represent? Right here, this is my change in x, right? My delta x. And this over here is my change in y, right? Or change in f. Okay? So when we divide change in y or f over change in x, like you said earlier, what is that actually?
Oh, wonderful.
So basically the average rate of change is pretty much the slope, right? We want to be clear though. Okay. Right, because slope is delta f divided by delta y, x, right? Yeah. Okay. So the average rate of change of f is the slope of f between 0 and 2. Okay, so what is this line called? Do you guys know?
Which one?
The blue line that I made? The straight line? The only line.
Well, technically, if you zoom in,
It's called the secant line. Sorry, I spelled that kind of weird. Secant line. Have you guys heard that word before? It is actually related to cosecant, but that's for another lesson. So this is a secant line, okay? It's a secant line because it crosses the curve at 2 points. Do you guys remember in geometry, in the circles, there's tangents to the circle and there's secants to the circle?
they don't
Remember?
They only do 10.
So like, when you have a circle, like a tangent, it crosses the circle once, and a secant line is like a chord, it crosses it twice. So this is a secant because it crosses the curve twice, yeah?
Yeah.
Okay. So what we can say is,
Wrong.
So the average rate of change of f is the slope of the secant line. Now, there's a lot of terminology here. Like, there's a lot of things that are equivalent in this section, so you have to keep track. Average rate of change is slope of secant line, okay? And the slope of the secant line, where? Because there's many secant lines, but the secant line that passes through the two endpoints of the interval, okay? Does that make sense? Whew. I already start to feel the sugar coming in. Thank you so much. Okay? So next example is says find the slope of the secant line. I've already shown, so go ahead and, well, first of all, what is the secant line? How am I going to make the secant line? Just connect to A and B. And there's our secant line. Okay, if you guys want a ruler, you could go ahead and grab one over there if you like. The slope of the secant is going to be change in y over change of x, which is going to be, okay, what is the final y value? The y value is 7 minus 13, because I'm going from A to B. And from 2 minus 1, so it's going to be negative 6. So that's the slope, right? Is that okay? Any questions on this? It's okay, right? That's okay. Now, can we generalize this so that it applies to not these specific numbers, okay? So let's say we started at A, okay? I'm gonna do it in pink this time. Let's say we start at A, and we're gonna go to B, right? But instead of calling it B, let's say we went all the way to wherever A was, but we added H, okay? A plus H. Does that make sense? Okay. So, what's the length of our interval? What does H represent? The change in x. So this one is actually just h. So you start at A, but you move over h, so then you end up at A plus h. That makes sense, right? So initially our y value here is f of A, right? But eventually we move down on this case. In this case, we move to f of A plus h. Does that make sense? Yeah? H is a change in our x value. A change in x is h. And so since when I was at A, my y value is f of A. When I was at A plus h, my y value is f of A plus h. Because this could work for any function, not just this one. I'm trying to generalize. That's okay? Everybody cool with me so far? Okay. So then how can I generalize to do this, get the slope of the secant in general? Okay, the slope of the secant in general. What's that? Oh, next door. The slope of the secant is going to be delta y over delta x, right? So how do we find a change in y? It's going to be f of A plus h, right? Minus f of A. You guys see why I wrote that? Because it's my final f minus my original f. Yeah? Over what? What's my change in x? h. You see that? So that's a general equation.
A plus B plus B.
Have you guys seen this before?
Yeah, on those ones that you had to plug in the other way around.
Uh-huh. Okay, this has a special name. Well, it's a fraction, right? What's another word for a fraction or when you're dividing? Ratio. Okay, what's one that starts with a Q? Quotient. This is a quotient, but it has a special name, a special kind of quotient. We're finding the difference between where we start at A and then our final value. Yes, final and original. So this is called the difference quotient. Okay? In fact, if you look on the next page, there's a line for it. But you guys preempted it. Very good. Yeah, you guys learned this, right? Difference quotient?
No.
Oh. All right. Did everyone get that? All right. Next page. All right. So. Okay. Oh, I'm kind of sad that my computer thing is not working right now. Okay. Let's do this. Let's go ahead and really quickly sketch on the whole page. I never done this before, but let's just take the whole page to make a graph. Let's do it like, I don't know, make it kind of steep. And let's do what we just did, okay? Let's start here at A and go wide. Go wide! Okay, to A plus H, okay? Oops. Oh yeah, this time it is like that because it's an increasing function. Okay? Oh my gosh, I'm spilling nuts everywhere. Alright, so make a speed secant line. Okay? Woo! I feel the life coming back into my body. The blood. When I was in my first year of teaching, this happened to me after like lunch. I think I didn't have lunch or something in 5th period. I was like, you guys. Oh no, I was super hyper. I was like acting super hyper, and then I was like, okay guys, I can't teach anymore. And they're like, what's wrong with you, miss? You're so emo. You were like so hyper 1 second, and now you look like you're gonna die. That's what they told me. Okay, how am I gonna approach this? All right. Now what if? Okay. All right. What if? This is a secant, right? But there's another type of line. The tangent line. What's a tangent line? It only touches the curve at 1 point. Okay, this touches the curve at 2 points. But can you imagine a line that touches the curve only at 1 point?
Yeah.
Like how?
Change the slope a little bit.
Change the slope a little bit. So it's kind of, think of it like a bullet grazing, just grazing the head, right? So if I were to do something like not like this, but change it like this maybe, right? Then it would be tangent, right? It would just touch the slope at 1 point, right? You see that? If I wanted to find that slope though, how do I find that slope?
You gotta find something with the original line, like the line, the curve.
Because when you find a slope, you always have to do delta y over delta x. But that means how many points do you need for delta y? You need change. You need 2 points. You need one a here and an a plus h. But if I'm doing this, what's my other point? Well, my first point is a. Where's my other point?
It's only touching at one.
In the middle of where?
A and H.
Oh, here?
Yeah.
Oh, go straight up.
And then you divide.
Like that? Okay, wait. I think you might be onto something. So I'm going to use a different color and try that. Okay, she said go to the middle. Okay, so let me find another color.
Wait, are you testing us, or are you
No,
really
no, no.
asking?
That was your idea.
Just trying to get us to think together.
No, I'm trying to figure out how to do this because if I want to know, okay, that's the slope of the secant, but I want to know the slope of the tangent.
Ooh,
But
what's
how,
that?
you know what I mean? So let's just do this. Can we? So in the middle, let's call that a plus half of h. Why don't we just call it h2? Okay. So that was our first h, but now our h is gonna get smaller. We're gonna move a little closer. Yeah. So over here. Okay. We're gonna cut that interval in half. Oops. Oh, that was awful.
Yeah, mine is still gonna cross.
So that was better, but what happened, Josue?
Still cross it.
It's still cross. So it's still a secant, huh? Well, obviously, because you picked a point, right? You picked a second point. What do you think? But did it get closer? Is my purple line? That's awful. I'm so sorry that happened. I'm so unfortunate that it.
So if we can draw a graph.
No, because how are you gonna calculate the slope? No, just eyeball it. No, just draw this other secant. So, but okay, if the tangent that I want is like this, right?
Oh,
Am I getting closer though?
yeah.
The purple line, based on Arlene's idea, is that closer to the secant than the pink?
Yeah, let's get closer to
So if I get closer, you think it'd be even closer more to what I want?
A. Yeah.
Okay, so let's try one more time. So I'm gonna pick halfway. It's kind of like that first day when I said get closer and get closer and get closer to the wall, right? Remember? And I was like, go in half. So now we're gonna do a plus h3. This time,
So we do draw the other state?
She says
Yeah.
it's supposed to touch the wall.
What?
Yeah, it's supposed to touch the wall.
okay, now are we closer to what we want? How are we gonna get there though? Should we just go closer?
What if it's just A?
But you need 2 points to make a slope, right? Do you guys kind of get what we're doing here? So if we got really, really close, like
Wait, did you make a
What if
tangent?
it's off the circle?
no, not the
I
tangent,
mean, off
the
the
secant.
line. What if it's off the curve? The second point.
But how are you gonna know where to put it?
But this already looks like a line.
Like a tangent, you mean?
It's like a line.
Okay, so you guys agree that every time we moved our h closer or make the h smaller, then the secant line starts looking more like the tangent that we want, right?
Yeah.
So what if our h was like really, 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 really small, like 0.00001? Then we still have 2 points, but it's gonna be really close, so it's gonna be very similar to that it's still gonna be a secant, but it's gonna be very close to the tangent, right? What are we doing by getting closer and closer and closer and closer? Or making our h smaller and smaller and smaller and smaller? What are we finding or calculating? Something that we've been learning about all.
Limits.
We are doing. We can use our idea of limits, huh? You guys see? What the limit of what? As who goes to where?
Limit as A approaches H.
As a approaches h,
As H approaches A
x approaches a.
from the right.
Oh, okay. That's one way to write it. That's definitely one way to write it. The x value is approaching a. Instead of being all far away, it has to get closer and closer to a, and that's definitely right. There's another way to think about it, and the way she just said it, we're gonna think about it we're gonna call it that later after we learn some more stuff. But just historically, the way Newton first thought of it, as what does this represent? What is this?
Change x.
Yes, change in x, and we call that what?
H.
H. And what are we doing to h?
Shrinking it.
We're shrinking h, and we want it eventually to the limit as h goes to what? No,
0.
0. We want h to get really, really small. Now remember, the limit as x goes to 0, does x actually have to touch 0? No, it doesn't actually have to touch 0. We just want to know what it's going to approach as it gets closer and closer to 0.
When you're talking about as h approaches 0, it's like
Yes.
Because
So-
it starts at after A.
Either we want the x value to approach a, or we want the h value to approach 0. It's the same thing. Okay? Because right now h is this, right?
Yeah.
But then here h is this. And here h is this. So we want h to get smaller and smaller and smaller. Right? Or you can say we want that second x value, or I guess you could call it the second x value, a sub b or a sub 2. We want that because this is the first x. The second x, we want that to get closer and closer to a. Okay? So good, very good. And I wish I could show this to you on my computer tomorrow, I will. But alright, so that's what we're gonna do. To find the tangent slope, wonderful, wonderful. Where's my cord? Okay, so we're gonna call, you guys understand, we don't have to write in our notes. The tangent is the line that touches the curve at one point. Okay? To find the tangent slope, we're gonna do this. The slope is gonna be the difference quotient, right? F of a plus h minus f of a over, okay, what was the difference quotient? F of a plus h minus f of a over h, because that's the interval, right? But it's not just that, we're gonna do what to it? We're gonna take the limit as what? As h approaches 0. But wait a minute, if h approaches 0, we're gonna have a 0 in the denominator. So we're not gonna plug it in, but we just wanna know, we're not gonna say h equals 0, we just wanna see what happens as h gets really, 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 really close in the neighborhood of 0. Okay, and that will help, and if we can calculate that using limits, then we'll be able to figure out what the slope of that tangent is. Okay? So we also call this the tangent slope. We also can call that the slope. Oops, the slope of the curve. Okay? Y equals f of x at the point, whatever my a is and what f of a is. Okay? So for example, earlier we drew a line here, and if we have this line, okay, I'm just sketching it, that's a tangent. Okay, that's a tangent line because it touches the graph just once. It skims it like a bullet. Okay, this is crossing, this is, let's assume this is a right here, and this is f of a over here. So the slope of the curve, because when you're in algebra 1, you could only find slopes of lines. But now we're going to talk about the slope of a curve. And the slope of the curve is just the slope of this line that skims it at one point. Okay? So right here, the m of this line is the slope of the curve. It's the slope of the curve. So we could call it the slope of the tangent, or we could call it the slope of the curve. Okay? Is anybody kind of confused right now? Which is totally fine because it's a new idea. Is this okay?
The slope of the line is the slope of the curve.
You guys feel good? What was that?
The slope of the line is the slope of the curve.
The slope of the line, okay, yes. So the slope of the tangent line is also equivalent to the slope of the curve at the point. So we know how to find slopes of line. We know what it means to find the slope of a line, right? That's easy. But if I ask you to find the slope of a curve, if it's not a line but it's curvy, how do you find? You can't just find the slope. This curve has many slopes. We can only focus on one point at a time. So let's just pick a point. And if I ask you what's the slope of this curve right there, then what you have to do, you can zoom, yes. Or you can draw a tangent line and so basically asking for the slope of the curve here is the same thing as the slope of whatever that tangent line is there. Does that make sense? So the slope of the curve at a certain point is equivalent to finding the slope of the tangent line to that point. Does that make sense? And how do we find the slope of the tangent line? Well, we can find the slope of a secant line close to it and just bring that secant closer and closer and closer, make that interval smaller and smaller and smaller. Does that make sense? So, to reiterate one more time, the slope of the curve of a function at a point is basically equal to the slope of the tangent line. Tangent line to the curve at that point. Because before this, you've never learned about how to find the slope of a curve, right? Just slopes of lines, right? But in calculus, it's all about finding slopes of curves because life is not all linear. Life curves and changes and turns. Okay? So let's think about it. If I can tell you, okay, I went running for 2 hours and I ran 10 miles, then I know my average rate of change was 10 miles over 2 hours, so I was going 5 miles per hour, right? That's giving me an average rate, okay? But what if I want to know more, like maybe I'm an Olympic runner and you want to know more information, like, well, it's like, well, in 1 hour I was going 5 hours, so you're going 5 miles per hour, but you want to know how much you went over 30 minutes. Like you want to, like, what if you don't want to just know how much you went over, like what your speed was over that 2 hour interval? You don't want to know just your speed over that 1 hour interval. You don't even want to know your speed over that 10-minute interval. What if you want to know what your speed is at every moment? At every second, not even less than a second, a moment. You see what I'm saying? Then you're not finding average rate of change anymore because that's too broad. I want to know at this time, what's my speed? That is instantaneous rate of change, which is the slope at that moment. Because look, right here, my slope is like this. My rate is like this. But 1 second later, it's going to be a little less. It's going to change. And so I care about the slope at that moment. Then I don't want average rate of change. I don't want the secant line anymore. I want tangent line. I want my rate at that moment. Think about economics. What if you want to know the rate of production or the rate of change of the price or something? The businessman doesn't want to know, okay, just tell me the rate over the whole day. No, they want to know every single time because who knows if the stock market is going up and down. They want to know the rate of change at every single instant, you know? So that's instantaneous rate of change. Okay, so the expression, okay, does that make sense? The expression f of a plus h minus f of a over h is called the difference quotient. Oops, got too excited, wrote too big. Quotient, okay, of f at a. This is also called the slope of the, okay, the difference quotient is the slope of the, no, the difference quotient is the slope of the secant line. You see that? But once you take that difference quotient, take the limit of it, then you get the slope of the tangent line. Get me? Okay. Remember, the difference quotient is just this part, right? And this, remember, just gives me the slope of the secant line, right? But if you find the limit of this, that will give me the slope of the tangent line. Meaning, over here, the difference quotient is what we use to find the secant lines. But once we find the limit of that secant line, as the secant line goes to the h goes to 0 on the secant line, then we find the tangent line. Okay? All right. Now, good. Very, very good. So now let's actually move from conceptual to actually looking at a problem. Okay? Let's bring it down. Let's bring it home. Okay? So at the indicated point, now remember, when we're talking about instantaneous rate of change, which is tangent line, you have to specify an instant. Because if you don't specify which instant you're talking about, which x value you're talking about, you have totally different tangent lines. So when you're doing instantaneous rate of change, you have to specify which, not interval, but which instant you're talking about. So at the indicated point, at the instant that you want, find, first of all, the slope of the curve, which means what? If I ask you for the slope of the curve, what am I asking for? Well, no, the slope of the curve. The slope of the curve itself is the tangent one, okay? So this is asking for the tangent, okay? And the equation of the tangent. So I want the slope and the equation. Do you guys know how to find slope? Yes. Do you know how to find equations? Yes. Point slope form, right? So it's easy. It's algebra 1. Okay, now you're starting to see already like why we did what we did in our summer packet, okay? What's the graph we're using? x squared minus 4x, which looks like a parabola, right? The instant we're in question is x equals 1. So let's just do the math, and then we'll look at the picture later. So first of all, they want the slope of the tangent of the curve, right? So we want the limit, the slope is going to equal the limit as h goes to 0 of f of a plus h minus f of a over h, right? According to the definition, that's how you find the slope of a curve, right? But what's our function? X squared minus 4x, right? And what's our a? Our a is where we actually, our x value, that's 1, right? So basically, I'm going to take it one step at a time. We want the limit as h goes to 0 of f of 1 plus h minus f of 1 over h. Do you guys see what I just did there? Basically, what I'm saying, okay, so actually, let's go ahead and draw the picture now. Let's draw a picture of the graph. It's going to cross the x-axis at 0 and 4, right? So let's just draw a parabola. Okay? There's a parabola. They want you to find the slope at 1, x equals 1. So if this is 4, 2, 0, they want you to find the slope at 1. Right here. Okay? And I surmise that my tangent, I'm just going to eyeball it, is going to be something like this. Looks like my slope should be at least, what's the sign of that slope? Is that positive or negative? Negative. So our answer should be negative. Okay? The question is, what's the slope of that line, right? Because they said find the slope of the curve at x equals 1. At x equals 1, what is that? The tangent. The slope of the curve is the slope of the tangent. And what's the slope of that tangent? Okay. So what are we going to do to get there? I'm going to use a pencil for this so I can erase it. We're going to start at 1, and that's why we're going to make 1 our a. Okay? And I'm just going to add h to it. Okay? So let's say this much is h, right? If that much is h, I'm going to find the slope of this line. And then get closer, make that h smaller, slope of that line, that line, that line, that line, that line, that line, until it approaches the tangent that I want. Does that make sense, you guys? Yeah? H is not defined because h is just moving closer. You can start anywhere and get closer and closer and closer. So let me draw it. Let me zoom in a little. Oh, interesting. Ooh. Okay. So let's say I start off with my h being right here. I mean this much being my h, okay? Then my a plus h is going to be right here, right? And so my anchor is a equals 1. And so I'm going to find the tangent, the secant of that line, right? But that's not close enough. So let's say I move a little closer, right? And then I moved closer, and so then I find the slope of that line. Oh. And then I get closer and closer until I hit h is 0 and I get the tangent line. The pink line, yes. My goal is to find the slope of the pink line, but since I can't do it directly because I can't find the slope with using only one point, I'm going to find it indirectly by creeping up on it through the secant line. Does that make sense? Yeah. Give me 1 second.
So you basically, for the secant line, you're going to try to find a secant line where crosses 2 points or really close to each other?
Say that again?
So like, to find the tangent line, you're going to have a secant where the 2 points, like where it crosses the curve, if they're really close to each other?
Yeah, but you're not just doing it once, you're finding the limit of that secant as the h gets closer and closer and closer until it disappears almost. Yeah. Exactly. Visual calculus. I want you guys to see this. It's not visual. Okay. Tomorrow I will show you guys that actually happening. Definition of tangent line, difference quotient. Give me 1 second. Why? All these people teaching calculus, they cannot. Okay. Let me just draw it one more time. Because that zooming in didn't help at all. Okay. So let's try to make it steeper. Okay. So if I start out, huh? Oh, I'm just saying, like, just take a different example. So if this is my A and this is my A plus H, that line is not quite where I need to be, right? Because where my goal to be, how come my markers here? Period. I hate that. Okay, so my goal is to get here, right? Where I'm just touching it once. So if I make my H smaller, then I'll be there. Make it smaller, I'll be there. There. And eventually, what the limit of these slopes is going to be the purple slope. Okay? So that's what we're doing mathematically. Okay? So the whole question was, why is my A 1? Because A is the point, 1 is the point where I want to find the tangent at x equals 1. So that's my anchor point. All my secants are at least going to have that as the anchor. Okay? So that's why we plugged in 1. Okay. Are you guys okay with that so far? All right. Sorry for that little digression there. Okay, so now let's actually plug in the function. The limit as h goes to 0 of the function is x squared minus 4x. So let's do, now remember, this is why you needed, I needed to make sure you guys knew how to do this from your summer packet. X squared, the argument is 1 plus h, right? That's right. So minus 1 squared minus 4 times 1.
So then whatever the function, you put that in that case.
Yes, so whatever's the argument, you put into the x, right? So do you see how this is, we'll write this down first. All under h? Yes. Now, you guys are going to make a lot of mistakes in the algebra. So please be careful when you're plugging this in. First, we plugged in the x value into the a, and then we plugged in the argument. So here the argument is 1 plus h, right? The argument is 1 plus h, so we're going to put 1 plus h into this formula. 1 plus h squared minus 4 times 1 plus h, right? And then here the argument is 1, so I'm just going to plug in 1. 1 squared minus 4 times 1. You see what I did? So just be very careful. Okay? There's a lot of room for mistake. The other thing that really important and really bothers me if you don't do it, even if you don't do the right thing in the end, is parentheses. Okay? So let's keep our parentheses straight. It's this thing minus this thing. You know that after parentheses you can use brackets, right? As another level of parentheses, of grouping. Okay. So now that's so easy to make a mistake here in your algebra. So first of all, keep the limits. We're still finding the limit. Okay, the limit as h goes to 0 of, now what's 1 plus h squared? It's going to be 1 squared plus 2h plus h squared, right? Yeah? Minus, don't forget to distribute the negative. That's another big opportunity for error. Minus 4 minus 4h. Yeah? And then we have a minus here. 1 squared is 1 minus 4. But that thing is all subtracted, okay? all over h. Now you guys should be able to do this without me. Now we can start combining like terms, right? So don't forget to distribute this negative. So we should in the end have an h squared and a 2h. Oh wait, 2h minus 4h, so that's negative 2h. Right? H squared minus 2h. Then we have a negative 3 here, and then we're subtracting a negative 3, so that's going to be 0 over h. Which is going to be the limit as h goes to 0 of h times h minus 2 over h. And the beautiful thing about this is that the h's cancel. So we can actually now substitute. So the limit symbol is gone, and I'm going to substitute 0 minus 2. So my slope is negative 2. Do you see why we had to learn limits before we learned this? Yeah? You ain't seen nothing yet. Everything's going to come together when we learn the fundamental theorem of calculus. This is just one piece of the puzzle, a small piece of the puzzle. You guys okay with that? So what just happened? We found the slope, didn't we? Isn't it? What is the slope of this line? The slope of this line, the tangent line, is negative 2. So the slope of this curve at x equals 2 is negative 2. Okay? So that would get you that 1 point. Okay? Or 2, I don't know. So this is the slope of the tangent line at x equals 2, at x equals 1. You can also say it's also called the slope of the curve, or you could call it the slope of x squared minus 4x at x equals 1. So you see how it's the same thing. The slope of the tangent is the slope of the function at that point. Okay? What did the other problem ask you to do? Find the equation of what? Equation of the slope of the tangent line. Do we know how to find the slope of a line? That's cake, right? The slope is negative 2. Our point is what? Okay, well our point is 1 comma, what's f of 1? F of 1, okay, f of 1 is going to be, well it's 1 squared minus 4, right? So it's negative 3. If you have a point and a slope, isn't that easy? We just do y minus negative 3, equals the slope times x minus 1. And you can leave it like that. But a lot of the times I like to put it like this. Okay? So a lot of times we use this form y equals m times x minus x1, and then we move that y1 to the other side. You see this? It's a positive 3, but you subtract it from both sides. And of course, if you really miss slope-intercept form, you could always say it's negative 2x minus 1. Those are both acceptable, but it's not necessary to do that extra work. Get me? Okay, so we just figured out how to use the limit of the secant line to find the slope of the tangent line to a curve, and use that and plug it in to find the equation of the tangent. Pretty cool stuff, huh? Yeah, so hold on. Oh. All right, so turn to the next page. And what's a normal line? Huh? The normal line is just like a tangent line, but it's the line that is perpendicular. I don't know why they call it normal. I think the explanation is in your book. Perpendicular to the tangent line at the point of tangency. I like that word, the point of tangency. That's fancy. At the point of tangency. Okay? So if we were to draw a parabola again, if the tangent at this point A, let's just say it's this one, if that's the tangent, then the normal would just be that one, right? That's the normal line, and that's the tangent line. Okay, it's just perpendicular.
Even if it crosses like, no, it crosses one point.
It does have to cross once.
But it crosses the same.
Point, at the same point, yeah. At the point of tangency. The point of tangency is that point. Okay? And how do you find a line that's perpendicular to another line? Their slopes have to be opposite and
Reciprocal.
reciprocal. Reciprocal means you flip the fraction, but opposite means you negate the sign. So if it's positive 1/2, then the perpendicular line will have -2. Or if the slope is 2/3, then the perpendicular will be -3/2, right? So it's opposite and reciprocal. Opposite means, doesn't mean reciprocal. Opposite means negative, right? So for this one, very good. So this slope is -2, so the normal line will have a slope of positive 1/2. Okay, and so we could continue with that tomorrow, but very, very good. You should be able to do the homework now, the rest of the homework for 2.4. So you're doing the first part, right? So Aki, today is the 9th, it's my brother's birthday. You're gonna do this one. Okay, then tomorrow I'm gonna assign this one. And then we're gonna review.
Wait, that's it? You just
Yeah.
92, 1 through 7?
You're doing all of this. Well, you already did this, but so you're doing all of it by tomorrow. Okay, please don't get behind in your homework this week because we're having tests on Friday and we're having retakes at lunch tomorrow. If you want to do the retake, make sure you bring your test corrections. Let me no. Show of hands. How many of you guys are planning to do retake tomorrow? I need to know how many copies I should make. 1, 2, 3, 4. Wait, 1, 2, 3, 4, 5, 6, 7. 7 retakes. Okay. All right. So today's Tuesday, right? So tomorrow okay. So tomorrow we'll do a little bit more notes and then review the whole unit. Thursday we do more review, and then Friday we take the test. Bam! And then we move on to derivatives. Today at lunch I have a meeting, it turns out. I just found out this morning, but today I'll be here after school. Oh, I have a meeting after school. Never mind. Tomorrow. Oh yeah. Aww. If you have questions, I have until 3:45 after school today. Yeah, so I have like 20 minutes after school.
Attention everybody, we are now on lockdown. Attention everybody, we are now on lockdown. Please do the...
Lock the door, close the shutters.
We are now on lockdown, everybody. Everybody, we are now on lockdown. Please proceed to your classroom. Students as well. Everybody lock up. We are now on lockdown. This is not a drill.
It's not a drill? Oh.
Okay.
Should we turn off the lights, lock the door?
Yes, no?
We're on lockdown. What are you talking about? It's not time to be doing
You can still do homework during the lockdown.
This is not a drill.
Oh, I need to stop the video.
Oh my God.